Hello guys, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session of Work Energy Power, we discussed the lecture number 2. So where we focused majorly on the conservative and non-conservative forces, and then we also started the concept of kinetic energy and we solved some questions related to that, right? So now in today's session of Work Energy Power, that's lecture number 3, where we are going to focus on the Work-Energy Theorem, so which you are already familiar in your grade 9th level. So today we are going for the in detail explanation of the Work-Energy Theorem and the questions related to the Work-Energy Theorem. Okay, so most of the concepts which are related to Work-Energy Theorem, so the questions related to that we are going to cover today. Okay, chalo guys. So without wasting much time, so let's get into the today's topic. So and just I need your attention for next 1 hour guys. Just be with me, avoid all the disturbances around you, and at the end of the lecture it's a very important to prepare your own short notes. Okay, chalo. So with very high positive energy, let's begin the today's session with the question. Chalo. So before the question, let me write the kinetic energy formula as well, just as a recap. So in the last class we have started the kinetic energy, right? So if a body of mass m, if it is in motion having some velocity v, so then it possesses the kinetic energy. What's the kinetic energy? Half mv square, right? So based on the kinetic energy, let's do some questions, then we'll go for the work energy theorem. So try this question on your own guys. Try this question. What's the question says? An engine pumps water continuously through a hose. Water leaves the hose with velocity v, and m is the mass per unit length. See here, m is the mass per unit length of the water jet. So what is the rate at which the kinetic energy is imparted to the water? See here, what they are asking, the rate at which kinetic energy. So the rate at which kinetic energy imparted. So kinetic energy imparted to the water. Wherever I write Ke means it's a kinetic energy. So the rate at which kinetic energy imparted means rate means per second. So which means kinetic energy per second we required. The kinetic energy per second we required. Okay, chalo. So let's understand this question. How do we solve this? So first let's suppose this is a pipe. So this pipe, the water is being, the water pumps continuously through a hose. So from here the water is coming out. Okay, let's see. So then water leaves the hose with a velocity v. So this is a velocity v. So and m is a mass per unit length. So m is a mass per unit length. So let's find what is the total length of this water jet. First let's find what is the total length of this water jet. So that means, sorry. So what is the total length of this water jet? So the length of the water jet in 1 second, the length of water ejected per second. See here, so the length of water ejected per second. So that means in 1 second how much it will eject. So we know that speed is equals to distance by time. Speed is equals to distance by time. So here we need the distance we required, right? The length means the distance. So the distance is equals to speed into time. So here distance is nothing but speed into time. So what is the speed at which it is ejecting the water? V. So into the time in 1 second means 1. So that means the length of this is V. Understand the concept. So the length of the water ejected in 1 second is V. The V length water ejected. So m is a mass per unit length. See here. So m is a mass per unit length. So for 1 unit the mass is m. For 1 unit for mass is m. So for V units, so how much length the water ejected from the pump in 1 second? So the V units, the length is V units. So that means the length of the water ejected, which is going to be Vm. For unit length it's m. For V units it's going to be V into m. Simple thing, right? So V into m. So now we have got the mass per what is the V. For Vm is a mass. So the mass per unit length, the mass of water ejected is equals to mv, because the length is v and mass is m, so that's why mv, right? So then the kinetic energy imparted per second, the kinetic energy formula is half mv square. So in place of m, so the m is what here, mv into v square, so which becomes half mv cube. So try to understand the concept, guys, here. So why we are not taking mass as m, sir? Because the mass is changing per unit length. In 1 second the water ejected per v length. Okay, for 1 unit the mass is m, for v units the mass is going to be vm. So that means this total water ejected has the mass of vm. So that vm is the mass of water ejected into ejected water's velocity is v square. So that's why half mv cube. So option fourth one is the correct answer, guys. Understood the concept, everyone? Chalo. So let's go for the next question. So what is the relation between kinetic energy and momentum? So momentum we have studied it in the NLM, Newton laws of motion, and kinetic energy we just discussed now. So let's write both the formulas at one place. So the kinetic energy is equals to half mv square, right? And then we know that the momentum p is equals to mv. The momentum p is equals to mv. So let it be the equation number 1. So now what I am doing is, so let's write v is equals to p by m. V is equals to p by m. So now substitute v is equals to p by m in equation number 1. Substitute v is equals to p by m in equation 1. Substitute it in equation 1. So then what happens to the kinetic energy? So let's write it here. So then the kinetic energy will be equals to half into mass into, in place of v I am writing p by m whole square. So which is equals to half m into p square by m square. So here m gets cancelled, so that's why the p square by 2m. So the kinetic energy Ke is equals to p square by 2m. So this is the relation between kinetic energy and the momentum. So K is equals to p square by 2m. K is equals to p square by 2m. So from here we can also write, so the p square is equals to 2km. P square is equals to 2km. From there the p is equals to root over 2km. So p is equals to root over 2km, where k is the kinetic energy, p is the momentum. So simply you have to remember two formulas, guys, the relation between kinetic energy and momentum. So not only in this chapter, we come across in the other chapter, especially the electrostatics, and in the case of modern physics also we come across these formulas. Okay, so the kinetic energy K is equals to p square by 2m, right along with me, and then the momentum P is equals to root over 2km, root over 2mk, better write 2mk. Okay, so these are the relation between momentum and kinetic energy. Clear, guys? Understood the concept? Sure. So let's move further. So let's take one simple question here. What's the question says? So two bodies with kinetic energies are in the ratio 4:1, are moving with equal linear momentum. So they both have the same linear momentum. So then the ratio of their masses, see here. So the Ke1 to the Ke2, so their kinetic energies ratios are given. So which is 4:1. 4:1 means 4:1. So let the kinetic energy half, in place of kinetic energy, shall I write root over, or else let's write this way. So p square by 2m1, p square by 2m, kinetic energy is equals to p square by 2m, right? So I am using that because they said the linear velocities are same, so that the linear momentums are same. So that's why in place of p, let it be p. So kinetic energy 2 is nothing but again p square by the mass of the second one is different, so m2. So they both have same momentum, so which is equals to 4/m. So p square cancel. So this 2m2 will go up, 2m2 by 2m1, so will be equals to 4/1. So from here 2 gets cancelled. So then m2 by m1 is equals to 4/1. But what do we require? We required m1 is to m2. See here, the ratio of their masses, we required m1 is to m2, so which is nothing but 1 is to 4. Simple question. Option 4 is the correct one. Clear guys, everyone? Chalo. So let's go for the next one. So the third question, try this on your own. Simple question. Two bodies of masses m and 4m. So m1 body has mass m and the second body has mass 4m. Now are moving with equal kinetic energies. So the kinetic energy of both the particles is same, right? Chalo. So the ratio of their linear momentum. So we know that the P is equals to root over 2mk. So the ratio of their linear momentums they are asking. So P1 to P2, the ratio will be equals to root over, so 2m1. So they both have the kinetic energy same. So let's write kinetic energy K. So then 2 constant. So mass of the second body be m2 into the kinetic energy K. So here I can cancel the, so root 2 cancel, root K cancel. I can write, so directly P1 by P2 is equals to root over m1 by m2. So P1 by P2 is equals to root over m1 by m2. So that's the only thing left. Root 2 gets cancelled, root K gets cancelled, right? So what is m1? So the m1 is m and m2 is 4m. So m cancel. So this is going to be, so 1 is to 2. So therefore the P1 is to P2. So which is going to be 1 is to 2. This is 1 is to 2. So option 1 is the correct answer guys. Clear? Understood everyone? Sure. So let's move further. So the question number 4. What's the question says? If kinetic energy of the body is increased by 300%, so then the percentage change in the momentum will be. So to solve this kind of questions, let's follow the simple method. So so the initial kinetic energy, I am taking it as Ki. Let the initial kinetic energy is 100, I am taking. So now the kinetic energy increased by 300% means, so the final kinetic energy will become 400. The final kinetic energy will become 400. Yes or no? So now, so what is the change in kinetic, percentage change in the kinetic energy? Yes or no? So what is the percentage change in the linear momentum, not kinetic energy? What is the percentage change in the momentum? So we know that P is equals to root over 2mk. Yes or no? So if kinetic energy, initial kinetic energy is Ki, what is the initial momentum? Root over 2m. Ki is the initial momentum, right? So which becomes 2 into, so mass is, let it be m itself. So the initial kinetic energy is 100. So I can write it as 10 root 2m, let it be. This is the initial momentum. And final momentum will be root over 2m into the kinetic energy final. So which is root over 2 into mass m into what is the kinetic energy final guys? 400. Yes or no? So 400 root is 220. So take it out. So root 2m. So we have got the initial momentum and final momentum. So can we find what is the change in momentum here? Can we find what is the change in momentum? So the final momentum minus initial momentum. So what is the final momentum? 20 root 2m minus 10 root 2m. So which is nothing but, so 10 root 2m. So 10 root 2m, right? Sure. So this is the change in momentum. But what we required, so the percentage change in momentum. So the percentage change in momentum will be equals to, so it's a change in momentum by original momentum into 100. It's a change in momentum by original momentum into 100. So change in momentum by the original momentum into 100. Right. So what is the change in momentum here? So change in momentum is final minus initial. So how much we got? 10 root 2m is a change in momentum. Delta P is a change in momentum. And initial momentum is what? Again 10 root 2m. Yes or no? So into, so the 100. So here 1 into 100 is, so the percentage change is 100%. So the percentage change is 100%. Option 1 is the correct one. Clear guys the concept? Chal. So now let's go for the work-energy theorem. See, this work-energy theorem is always valid. First thing is, the work-energy theorem is always valid. So what is this like what work energy theorem says? You already studied. So the work done by all the forces, will be equals to the change in kinetic energy. The work done by all the forces is equals to change in kinetic energy. So whether it is the conservative force or non-conservative force, so the work done by all the forces will be equals to the change in kinetic energy. So here let me take, so the work done by gravity plus the work done by normal force plus the work done by tension force plus the work done by friction. So like that you can take n number of forces which will be equals to the change in kinetic energy. So change in kinetic energy means here you can write, so the final kinetic energy minus initial kinetic energy. So KEF minus KEI we can write. Okay, so this is clear, right? This part is clear, everyone? Chalo. So let's move further. So we can also let's derive this formula. So how it is change in kinetic energy. So just remember this one. This is always valid. So this is always valid. Remember this. Now, so to derive this, so what I am doing is, so let's consider, so there is a vehicle initially, so then, so some force is applied on it, so that it moved by very small distance, so the ds, let's suppose it moved by very small distance ds. So the very small work done in this case, so the very small work done dw is equals to the force into, so the very small displacement ds. So the dw is equals to force into ds, right? See, we are not doing anything complex thing here. So just initial, the body is there, so and we applied some force, so then the body has moved by very small distance ds. Okay, and then so what is the work done in moving the small distance ds? So dw. So then here the dw is equals to f dot ds. This is what I am writing here. So then the dw is equals to, so in place of f I am writing ma into ds. So now let's write, so let the body has, so the initial velocity, let the initial velocity vi and the final velocity vf. Okay, chalo. So now I am writing the dw is equals to m into, in place of acceleration, so let me write dv by dt, we can write, right? So into ds. So let me rearrange the terms here. So the dw is equals to m into dv into, so ds by dt, dv into ds by dt, right? So chalo, so we can write here the dw is equals to m into dv into, so what is ds by dt? So the velocity s. So from here, so the dw is equals to mv dv, right? So now, so let's write it in the next slide. So we have got, so the work done dw is equals to mv, so dv. So now let's integrate it on either side to get the complete work done. So mv dv integration. So now, so the integration of dw is, so the total work done, so mass is constant, m take it out, so and then v integration is going to be, so v square by 2, yes or no? So from where to where you are integrating, so its initial, with respect to v means its initial velocity vi and its final velocity vf. Yes, now see here, so the work done will be equals to m into, so let's integrate it from vf and vf, vi vf. So vf square by 2 minus vi square by 2, right? So upper limit minus lower limit we have to substitute. So from here I can write, so w is equals to m into vi square, right? So that means this is nothing but, so what is this? This is a kinetic energy final, KEF. So this is KEF minus this is KEI. So the kinetic energy final minus the kinetic energy initial. So that's what we wrote, right? So the work done will be equals to the change in kinetic energy. So this work energy theorem is always valid. Okay, so the work done by all the forces is equals to the change in kinetic energy. Understanding, guys? Here I just consider the one force, which is F. So but if there are some other forces also acting, you can take it as the work done by all the forces is equals to change in kinetic energy. Done? Clear? So just the basic derivation, not much complex. Chalo, so let's move further. So let's take one simple question, guys. Here, what's the question says? Try along with me, pause the video and try this question. A particle of mass m moves with velocity v is equals to a root x, where a is a constant. Find the total work done by all the forces during a displacement of x is equals to 0 to x equals to d. See here, velocity is given, so its mass is m, so we have to find what is the work done. So to find the work done, actually we have the formula F is equal work done is equals to F dot S. So whenever the force or displacement are missing, here force is not given and the displacement okay given, but the force is not given. The force is not given. So in such cases this formula will not work. So this formula will not work. Okay. So you have to go for the work-energy theorem. So work-energy theorem. So I am using the work-energy theorem. So what's the work-energy theorem says? So the work done is equals to the change in kinetic energy. So kinetic energy final minus the kinetic energy initial. Yes. So a particle of mass m moves with velocity v is equals to root ax. Okay, fine. So then, so find the total work done. Okay, fine. See here. So the displacement x equals to 0 to x equals to d. So let's do one thing. So okay. So let's or else let's go for this. So the work done is equals to the integration of f ds f dx. So here force is also not given, right? So let's go for work energy theorem itself. So the work done is equals to change in kinetic energy, KEF minus KEI. So but the thing is here, so we have got velocity, and displacement is this one. So v is equals to a root x, v is equals to a root x. So let the final mass half into a particle. Okay, fine. So initial ka 0, right? Yeah, fine. So no problem. So half into, so if the initial velocity, initial x equals to 0 means, so the initial velocity is 0, I can say. The initial velocity is 0. And why? Because x equals to 0, right? X equals to 0, initial displacement. So the vi will become 0. So at x equals to d, what will be its velocity? So the v final will be equals to a root d. So just simply substitute here. Half into, so the v final square minus half into m into the v initial square. So this will be equals to 0, guys, because the v initial is 0. So then half into mass into, so what is the v final? It's a root d. It's a root d whole square. So which becomes half into mass into a square into d. So this is the total work done, half m a square d. Half m a square d. So this is not, this is a 1, 3 by 4 no. So this is no. So second option is the correct option. Clear? Done? Chal. Let's move further. So let's go for the next question. So the question number 6, what's the question says? See here, guys. Velocity time graph of mass 2 kg moving in a straight line as shown in the figure. So the work done by all the forces on the particle. See here. So they did not give the force. So they are asking us to find the work done. See, in such cases, you can simply use the work done is equals to change in kinetic energy. So the work done is equals to change in kinetic energy. So kinetic energy final minus kinetic energy initial. That's it. So here I can write half mass into, so the Vf square, so the final velocity square minus half into mass into, so the Vi square, initial velocity square. So half into, so the mass of the particle is 2 kg. So initially this is a velocity time graph. So I can see that, so this is a V initial is 20 meter per second, and then particle has reached this point. So this is a V final, which is 0. So right, chalo. So the V final you can substitute 0 whole square minus half into mass is 2 kg, V initial is 20 whole square, right? Chalo. So here 0 is 0 into something 0. So here 2 cancel. This is going to be 400. 0 minus 400 is minus 400 joules is a work done. So therefore the total work done is minus 400 joules. See here, 400 is there, minus 400 is there. You have to take care of the sign as well, guys. Okay, so here the correct option is Chalo, so let's go for the next question, guys. So what's the question says? A body of mass 3 kg is under a constant force which causes a displacement s in meters in it. So given by the relation s is equals to 1 by 3 t square, where t is in seconds, work done by the force in 2 seconds. See here. So the displacement is given, but the force is not given here. So whenever the force or displacement, any one of these is missing, so blindly go for the work energy theorem. Okay, so what's the work energy theorem says here? So the work done is equals to, so change in kinetic energy, so I am writing half into, so the V final, or else you can write V2 square minus half V1 square, where V2 is the final velocity, V1 is the initial velocity. So but here we know only the displacement. So what is the displacement? So t square by 3. So but we don't know what is the initial and final velocities also. So first let's see the velocity function. V is equals to ds by dt, so which is nothing but d by dt of t square by 3, yes or no? So 1 by 3 comes out, so from here, so I can write t square integration is 2t, so which is nothing but 2t by 3 is the velocity. Now so they are asking the work done by the force in 2 seconds, which means, so if at time t is equals to 0, so that's going to be the v initial. So if t is 0, the v initial is 0, so that means v1. So if at time t is equals to 2 seconds, because in 2 seconds means 0 to 2 seconds, it means 0 to 2 seconds. So final t at t is equals to 2 seconds, v2 will be 2 into, substitute in place of 2 is 2, so by, so 4 by 3 meter per second is a final velocity. So now we have got initial velocity, final velocity, simply substitute. So half into mass is 3 kg, so the V2 is 4 by 3 whole square, right, minus this whole thing will be 0, yes or no? V1 is 0, right? So now I can write half into, so 3 into, so this is 16 by 9, so 3 ones are 3 3s are, so then 16 by 3 6, so 2 3s are 2 8s are, so which is nothing but 8 by 3 joules. So the correct answer is option 4, 8 by 3 joules. Clear? Chal. So let's go for the next question. So what's the question says? See here. A force acts on a 3 gram particle, so in such a way that the position of the minus v1 square, right? So half mass is given in grams here, 3 grams, so convert it to kg. So 3 by 1000 s into, so the v2 square minus v1 square. What is v2 square? 19 square minus v1 square is 3 square. So let's do this simple way. So half into, so we can write 3 by 1000 into, so this is 19 plus 3 into 19 minus 3, a minus b into a plus b we can do. So which is nothing but 22 into 16, right? So then do the simple calculation, guys. So what we are going to get? So 2 1s are 2, 11s are, and then so 11, so this is 33 into 16. So let's do what is 33 into 16. So 18, 6 3 18 19, and this is going to be 3 and 3. So 8 12 4 5. So 528 we are getting, right? So if it is 528, so we can write 528 by 1000, which is nothing but 528 millijoules. 528 millijoules is the correct answer. Option 4 is the correct one. Clear? Understood, guys, this part? Everyone? Sure. Simple questions. So let's go for the next question. What's the question says? So an object of 5 kg is acted upon by a force that varies with position of the object. So if the object starts out from the rest, so at x equals 0, what is the speed at x is equals to 50 meters? See here. So the force versus displacement graph is given. So can we find first what is the work done? The work done is equals to the area under fx curve. Just understand the concept. So area under fx curve. So right. So what is the area under fx curve? So we have got this is 0. So 25 into 10 plus, So this is triangle, half into base is 25, height is 10, right? So from here we get 250 plus, so this is 5 times, so 25 means 125, so which is nothing but 375 joules is the work done. So but what they are asking us to find what is its speed at 50 meters. So if it starts from rest, so now let me use the work energy theorem here. Okay, so the work done is equals to the change in kinetic energy. So what is the change in kinetic energy? Half mv2 square minus half mv1 square, half mv2 square minus v1 square. So the work done we already know, so which is 375 joules. So half into, so mass, what is the mass of the particle? 5 kg. So into v2 we have to find v2 square, and then this v1 is 0 because the particle starts out from the rest, so v1 is going to be 0. So then simply, so let me do this part here. So we can write here, so 375 is equals to, so half into 5 into, so let's cancel this one here. So here 5 ones are 5 sevens are 35, so 5 5s are, so then so send this to that side. So v2 square is equals to 75 into 2, so which is 150. So then from here, so the v2 is root 150. So is options are in decimals? Yes. So root 150 means the closest option I can put 12.2 meter per second directly, because 12 square is 144. So the root 150 means what, 12.2 meter per second. Clear? Understood? Sure. Let's go for the next question, guys. So what's the question says? See here. A vehicle of mass 10 kg is moving in x direction with a force with a constant speed 10 meter per second. It is subjected to a retarding force. It's subjected to a retarding force. So during its travel from x equals to 20 meters to 30 meters. So evaluate its final kinetic energy. See here. So the simple thing, again let's use a work done is equals to, so the change in kinetic energy. So what is the change in kinetic energy? Half mv2 square. Just understand the concept, guys. Half mv1 square. Now see here, in place of work done, the force is given. So and its displacement is changing from 20 to 30. So shall I say in place of work done, so shall I write x1 to x2, so the force in the x direction into the dx, because the force is only acting in the x direction. So which is equals to half into m v2 square minus half m v1 square, half m v1 square. So a vehicle of mass 10 kg is moving in x direction with constant speed of 10 meter per second. It is subjected to a force during its travel from x equals to 20 to 30 meters. So then find its final kinetic energy. So we have to find what is its final kinetic energy. Its initial velocity is 10 meter per second. So let's write. So the integration of x1 to x2, so it is 20 to 30. So it's a retarding force. So I am taking the force as minus 0.1 x into dx. Don't take plus here, because they clearly mentioned retarding force, which is acting backward. Object is moving right side, so the force is acting left side. Okay, so which is equals to half into, so or else let's write this as final kinetic energy minus initial kinetic energy. So this is a final kinetic energy minus, so what is the initial kinetic energy? Half into mass is 10 into, so the initial velocity is 10 square, right? So KEF is a final kinetic energy minus, so this is going to be 5, so 100 into 5, so the 500, right? So from here I can write minus is common, 0.1 is common, so the x integration is x square by 2. So from where to where? 20 to 30. So which is equals to, so the kinetic energy final minus 500. So kinetic energy final minus 500. So from here, so I can write, so 0.1 means I am writing minus 1 by 10 into, so substitute the upper limit and lower limit. So here, so x square means the 30 square, which is 900. So write 2 also outside, so which is minus 1 by 10 into 2 means 20. I can write here, it is 20. So 900 minus 400, so which is equals to kinetic energy final minus 500, right? So we need the kinetic energy final 500, so which is here it is 500, so into, so kinetic energy final minus 500. So mass is given in kg only, right? Yes, kg, so 10 meter per second square. Yes, fine. So 2 cancel, here 2 ones are 225 times, right? So then it is minus 25, so plus 500, so send this 500 to this side, so it will become plus 500 is equals to KEF. So therefore the final kinetic energy, so we'll get it as 475 joules. So it's going to be 475 joules. Option 3 is the correct one. Simple concept, just the formula based. So here we are using the different concepts to find the work done. We know that the area under the fx curve or integration of f dx will give the work done, and final kinetic energy we are finding, initial kinetic energy, so they gave the hints to find it. Clear? Understood? Chalo. So let's move further. So the question number 11, so what's the question says? A particle of mass 10 grams moving along a circle of radius 6.4 centimeters with a constant tangential acceleration. What is the magnitude of this acceleration if the kinetic energy of the particle becomes equals to 8 into 10 to the power minus 4 by the end of the second revolution after the beginning of the motion? So try to understand this question. See here. So this is a circular path. So where a 10 gram particle, so let's suppose this is a 10 gram particle, is moves along the circle of radius. This is the circle of radius 6.4 centimeters, let it be. So now with a constant tangential acceleration, so let the tangential acceleration will act along the tangent. So if the particle tangential acceleration is this side, means so there is some force which is acting on it. So what is that force? The tangential force is responsible for the tangential acceleration. So what is the tangential force? Ft, right? So then acceleration, if the kinetic energy of the part sorry will be equals to 8 into 10 to the power minus 4, just write the work energy theorem here. So what's a work energy theorem says? The work done is equals to change in kinetic energy. So what's the change in kinetic energy? Half m v2 square minus half m v1 square, half m v2 square minus half m v1 square. So fine. So chalo. So then, so shall I write in place of force work done? So shall I write force into displacement? Force into displacement. Yes. So force and displacement both are in the same direction. So that's why I am writing force is a tangential force into, so the displacement s into, so the cos 0, the angle between those two is cos 0 is equals to, so beginning of the motion means initial velocity is 0, yes or no? So beginning of the motion, and then they are asking the final kinetic energy is given. This is the final kinetic energy, which is 8 into 10 to the power minus 4 joules. I am writing in place of this kinetic energy, already they gave 8 into 10 to the power minus 4. So now let's change the terms. So use a simple concept here. The tangential force means, so mass into the tangential acceleration, mass into the tangential acceleration. So see here, it is completing the final kinetic energy is this much when at the end of the second revolution. So if the particle is started from here, then so it is completing the 2 revolutions, means for 1 complete revolution it covers 2 pi r. For 2 complete revolutions it covers 2 pi r into 2. So which means total 4 pi r is the distance covered by it. So cos 0 is 1, which is equals to 8 into 10 to the power minus 4. So what is the mass? 10 grams they said. So 10 by 1000. The tangential acceleration did they give? So what they are asking, what is the magnitude of the acceleration? They are asking the acceleration, let it be 80. So 4 pi value is 22 by 7 into the radius is 6.4 centimeters. So convert it to meters, 6.4 by 100. So which is equals to 8 into 10 to the power minus 4. So now let's do the simple calculations here. So here in the denominator it is 10 to the power 4. So here 10 to the power 4, 10 to the power 4 minus 4 gets cancelled. So the 80 into 88 into 6.4 by 7 is equals to 22 into 4, 88 by 7 into 6.4 is equals to 8. So 8 ones are 8, 11s are, right? So this becomes, so 80 is equals to, so we can write 6.4 that side. So here if we send 7 by 11, this becomes 7 by 11 into 6.4. So which becomes, or else let's write this way. So 66 by 7 means we can write, so 7 by, so 11 into 6.4. Yes or no? So calculations correct only, right? 0 0 cancel, 10 square, 10 square, 10 to the power 4. So if you send 10 to the power 4 to that side, 10 to the power minus 4, 10 to the power 4 gets cancelled, and then here 4 pi is 22 by 7. So you can take this value as 3.14, otherwise better, because everything is in decimals, right? So you can avoid the confusion. So 80 into 4 into 3.14 into 6.4, which is equals to 8. So right, so from here the tangential acceleration will be equals to, so you can send this everything to that side, 8 by 4 into 3.14 into 6.4. So this is 4 ones are 4 twos are, so then 2 ones are 3.2. So 1 by 3.14 into 3.2. So 1 by 6 means 0.18, 0.1 something like that we get. So which is nothing but option 3. So closely, so the closest option you can choose, so which is 0.1 meter. See, you do the calculation, guys. I am not sure whether it is 0.1 or not, so you do the calculation of this. So 1 by 6 something like that you get either 0.18 or 0.1. So you have to do the complete thing because the options are close. Okay, so you take this calculation as a homework. Chalo, so done. Chalo, next. So next, what's the question says? A particle of mass 50 kg is at rest. So is at rest means initial velocity is 0. Yes or no? So and then the work done to accelerate it by 20 meter per second in 10 seconds. So simple thing, the work done is equals to here half m v2 square minus half m v1 square. So what is half into m common? So let's write v2 square minus v1 square. So half m is what? 50 kg into what is v2 square? Final velocity is 20 square minus initial velocity, so it is 0, right? So then, so half into mass is 50, this is 400, so which is nothing but, so 20, so which is nothing but 1000 joules. So 1000 joules means 10 to the power 3 joules. Option 1 is the correct answer. Simple question, right? Chalo. So let's go for the next question. So the question number 3. A body of mass m was slowly pulled up the hill, a force F which at each point was directed along the tangent of the trajectory. So all forces are smooth. So find the work performed by this force. See here, a body was slowly pulled up. So this slowly pulled up means the change in kinetic energy is 0. So whenever they say in the questions, if a body is slowly pulled up or gradually pulled up, so like that, if they give the hints like this, so you can simply consider the work done by, the change in kinetic energy is 0. So this object, upon applying the force, very slowly they are moving it to top. Okay, so then, so what is the, all surfaces are smooth, find the work performed by this force. What is the work done by the applied force they are saying? See, for work-energy theorem, we know that the work done by all the forces is equals to change in kinetic energy. The work done by all the forces is equals to change in kinetic energy. So here, what are all the forces that we have? See here. So one force, that the surface is smooth, there is no friction force, right? So there is one normal force is acting, right? And one, what is this one? Applied force is acting, and one more force, that is mg is acting. So the gravitational force, right? So the work done by gravitational force plus the work done by normal force plus the work done by applied force is equals to change in kinetic energy, which is equals to 0, because the body is pulled up the hill very slowly, right? So the work done by gravity So the gravitational force is acting downward, mg, and then so body is displaced from here to here. So what is the displacement? Body is displaced from here to here, here to here. So what is the total displacement? H. So the displacement is upward, the force is downward. So that's why I am writing mgh into cos 180 degrees. And then so the work done by the normal, see the displacement is in this direction, so the normal is perpendicular to this surface. So that means the work done by the normal is 0, because so it's a perpendicular, right? And then so the work done by the applied force F is equals to 0. So from here, so this is minus mgh plus work done by the force is equals to 0. From here, the work done by the force is equals to mgh. So the work done by the force is equals to mgh. Option 3 is the correct one, guys. Understood the concept? Clear? Sure. So let's go for the question number 14. So 300 joules of work is done by sliding also. Whenever they say sliding, so again the change in kinetic energy is 0. Sliding 2 kg block up an inclined plane of height 10 meters. So there is a inclined plane of height 10 meters. Is the diagram given? No, here not given. So let's see. So this is a body of mass, how much? 2 kg. So this is the inclined plane, right? So this height is 10 meters. So then, so the 300 joules of work is done by sliding a 2 kg block up an inclined plane of height 10 meters. So what is the work done by friction? See, when it is moved up, so the friction will act in this direction. Yes or no? So now let me write. So the work done by all the forces will be equals to 0. The work done by all the forces will be equals to 0. So here the work done by, what are the forces? What are all the forces? The work done by applied force, let the force be applied force, and then the work done by friction plus the work done by normal plus the work done by gravity. So all will be equals to 0. So here let's write change in kinetic energy. So the change in kinetic energy is 0 because the body is sliding or gradually taken up or slowly taken up. So in all cases, so the change in kinetic energy will be 0. So here the work done by applied force is given. So 300 joules. Work done by friction we have to find. So the normal acts this direction. So the body displaces this direction. So the work done by normal will be 0. So because it's perpendicular. And work done by the gravitational forces. So gravity mg is downward and the body's displacement is upward. So mg into, so height is h. So the cos 180 is equals to 0 here. So simply here I can write 300 plus the work done by friction. So minus mgh. So minus mgh means mass is 2 kg, g is 10, height is 10. Yes or no? So cos 180 is minus 1 I wrote. So 0. So this is, so work done by friction plus 300. So this is minus 20 plus into 10. So this is 200. So is equals to 0. So this is work done by friction plus 100 is equals to 0. So which is work done by friction is equals to minus 100 joules. So the work done by friction is minus 100 joules. So here magnitude is only given, just simply put the 100 joules. Here the minus indicates the friction is acting opposite direction. Clear? Understood, guys? Sure. So let's go for the last question of today's topic. See, so consider a drop of rain water having mass 1 gram falling from a height 1 kilometer. So this is the raindrop which is falling from a height 1 kilometer. Okay, so its mass is 1 gram. So it hits the ground with a speed. So its final velocity before hitting the ground, it hits a velocity with 5 meter per second. Now take g constant with a value 10 meter per second. So what is the work done by the gravitational force? See, the first question, what is that? The work done by gravity is equals to, so its weight is mg and its displacement is also downward, right? So that's why directly I can write mgh cos 0. Its weight is acting downward and its displacement is also downward, right? It's falling now, right? So cos 0. So simply the work done by gravity is mgh. So what is the mass? Mass is given 1 gram. 1 gram means 1 by 1000. G is 10. Height. So from how much height is it is traveling? So 1 kilometer. 1 kilometer means 10 to the power 3. So 1000 cancel. So the work done by the gravity is 10 joules. So check the options. So the work done by the gravity, the first question, this is not. So 10. So this is correct. So this is minus 10. This is wrong. So directly you can go for the option 3. But there is one more question is also given. What is that? So what is the work done by the resistive force of air? So what is the work done by resistive force? So let's see the second question. Work done by resistive force. Work done by the resistive force. See, while it is traveling from top sorry guys, while it is traveling from top to bottom, what are all the forces we have? So the work done by gravity plus, so next what do we have? So the work done by the resistive force, right? So and what else, any other forces are there? So there is no normal force, there is no tension force, so there is no frictional force. So these two will be equals to, so the change in kinetic energy, so we have got, what is the change in kinetic energy? So see here, it hits the ground with 50 meter per second. So that means its initial velocity, while it is freely dropping, its initial velocity is 0, right? So initial velocity Vi is 0. So Vf is 50 meter per second. So can we find what is the change in kinetic energy? So the change in kinetic energy is half into mass m into, so V2 square minus V1 square. V2 square minus V1 square, right? So here I can write half into mass is 1 gram. 1 gram means 1 by 1000 I can write. So V2 square, final velocity is 50 square minus V1 0 square. So here I can write it as 1 by 2000 into, so 50 square is 2500, right? So here two zeros cancel, 5 4s are 5 5s are, so which is nothing but 5 by 4. So let's write it in decimals, which is 1.25 joules, right? So I'm substituting it here. So the work done by gravity plus the work done by resistive force is equals to the change in kinetic energy 1.25 joules. So from here the work done by gravity we got 10 joules plus the work done by resistive force is we have to find, and total change in kinetic energy 1.25 joules. So from here the work done by the resistive force is 1.25 minus 10. So the work done by the resistive force is minus 8.75 joules. So the work done by the resistive force is minus 8.75. Same thing we got. So that means like you can put the option directly with one question, because there is only 10 joules in one option. So but for your understanding I solved for this also. So this question was asked in NEET 2017 guys. Clear? Understood everyone? Sure. So that's it from my end. So this is the work energy power lecture number 3 guys. So in the lecture number 4 we will solve some questions related to the work energy theorem, and we'll also learn about the potential energy. Okay, so till then keep studying. All the very best. Bye.